welcome to our channel. Yes, today we're diving into the world of physics to explore the major contributors who have shaped our understanding of the universe. From the smallest atoms to the largest galaxies, the laws of physics govern it all. Join me as we journey through the cosmos, guided by the brilliant minds that dared to unravel its secrets. These are the giants on whose shoulders we stand, the pioneers who ventured into the unknown and returned with treasures of knowledge. Get ready to be inspired, to be challenged, and to have your mind blown wide open. This is the story of physics, told through the lives and legacies of its greatest heroes. Albert Einstein, a name synonymous with genius, revolutionized our understanding of space, time, gravity, and the universe itself. Born in Germany in 1879, Einstein wasn't always seen as a prodigy. In fact, he struggled in school, often clashing with the rigid, rote learning methods of the time.
But young Albert's mind was anything but ordinary. He possessed an insatiable curiosity, a relentless drive to question everything, and a remarkable ability to see the world differently. While still a young man, he imagined chasing a beam of light, a thought experiment that would later form the foundation of his groundbreaking theory of special relativity.
Published in 1905, Einstein's theory of special relativity shattered the Newtonian view of a static absolute universe. Einstein proposed that time and space are not separate entities but are interwoven into a single fabric space-time. And this fabric, he argued, is not rigid but dynamic, capable of being warped and stretched by mass and energy.
One of the most mind-boggling consequences of special relativity is time dilation, the idea that time flows at different rates for observers moving at different speeds relative to one another. Imagine two identical clocks, one stationary on Earth and the other traveling at a significant fraction of the speed of light. According to Einstein, the clock in motion would tick slower than the stationary clock.
Einstein's theories of relativity weren't just abstract mathematical constructs. They had profound implications for our understanding of the universe. They provided the framework for understanding the behavior of black holes, the expansion of the universe, and the very nature of gravity itself. Long before Einstein reshaped our cosmic perspective, Sir Isaac Newton laid the groundwork for our understanding of the physical world. Born in England in 1643, Newton was a true polymath, contributing to physics, mathematics, astronomy, and optics.
Newton's Principia Mathematica, published in 1687, is one of the most important works in science. It laid out his three laws of motion, fundamental principles that govern the motion of all objects.
Newton's first law states that an object at rest will remain at rest and an object in motion will continue in motion unless acted upon by an unbalanced force.
Think of a hockey puck sliding across the ice. It will continue gliding unless a player hits it or it encounters friction.
Newton's second law describes how the velocity of an object changes when subjected to an external force. This law is summarized by the equation F equals sine ma, where F represents force, Em represents mass, and A represents acceleration.
The harder you push a shopping cart, the faster it will accelerate.
Newton's third law states that for every action there is an equal and opposite reaction.
Marie Curie, a name synonymous with scientific brilliance and unwavering determination, shattered gender barriers and made groundbreaking discoveries in the field of radioactivity. Born Maria Skłodowska in Poland in 1867, she faced immense challenges in pursuing her passion for science in a time when women were largely excluded from higher education. Undeterred, she moved to Paris and enrolled at the Sorbonne, where she earned degrees in physics and mathematics, graduating at the top of her class. It was at the Sorbonne that she met Pierre Curie, a brilliant physicist who would become her husband and scientific collaborator. Together, Marie and Pierre Curie embarked on a journey of scientific exploration that would change the world forever.
Intrigued by Henri Becquerel's discovery of uranium's ability to emit mysterious rays, the Curies set out to investigate this phenomenon, which Marie coined radioactivity. Working in a dilapidated shed with rudimentary equipment, the Curies painstakingly processed tons of pitchblende, a uranium-rich ore, in search of the source of its radioactivity. Their efforts led to the discovery of two new elements, polonium, which Marie named after her native Poland, and radium, an element so radioactive that it glowed in the dark. Marie Curie's groundbreaking research on radioactivity earned her 2 Nobel Prizes, one in physics in 1903, shared with Pierre Curie and Henri Becquerel, and another in chemistry in 1911, this time awarded solely to Marie.
Niels Bohr, a Danish physicist, forever changed the way we understand the atom and the nature of reality. Born in Copenhagen in 1885, Bohr's curiosity led him to explore the atom, where classical physics failed. J.J. Thomson's plum pudding model depicted the atom as a sphere of positive charge with electrons like raisins. This model couldn't explain the discrete wavelengths of light emitted by heated atoms.
Bohr proposed a revolutionary model of the atom in 1913. He suggested electrons occupy specific, quantized energy levels, like planets orbiting the Sun. These levels are discrete, meaning electrons exist only at certain energy levels. Imagine a staircase where you can only stand on the steps. Electrons in Bohr's model occupy specific energy levels, not the spaces in between. When an electron absorbs energy, it jumps to a higher level, like climbing stairs. When it releases energy, it jumps to a lower level, like descending stairs. This quantum leap explained the discrete wavelengths of light emitted by atoms.
This concept formed the basis of spectroscopy, identifying elements by their light wavelengths. Bohr's model explained the spectral lines of hydrogen, the simplest atom.
Richard Feynman, a charismatic and unconventional genius, brought a unique blend of brilliance, playfulness, and clarity to the often intimidating world of quantum physics. Born in New York City in 1918, Feynman was known for his insatiable curiosity, his infectious enthusiasm, and his uncanny ability to explain complex concepts in simple, intuitive terms. Feynman's contributions to physics were as profound as they were diverse. He made groundbreaking advances in quantum electrodynamics, QED, the theory that describes how light and matter interact. QED is one of the most successful theories in physics, accurately predicting the behavior of particles and forces at the subatomic level with astonishing precision. Feynman's approach to QED was as unconventional as his personality. He developed a visual method for representing the complex calculations involved in particle interactions, using simple diagrams that have become iconic in the world of physics, Feynman diagrams.
Imagine drawing a cartoon strip to represent the interactions between particles. In a Feynman diagram, particles are represented by lines, and their interactions are represented by points where the lines meet. These diagrams provided a powerful tool for visualizing and calculating the probabilities of different outcomes in particle interactions, simplifying complex calculations and making QED accessible to a wider audience. Feynman's genius extended beyond his technical prowess. From Einstein's mind-bending relativity to Curie's groundbreaking work with radioactivity, these physics legends have illuminated our understanding of the universe. Their discoveries weren't just about equations and theories. They were about pushing the boundaries of human knowledge and inspiring generations to come. Thanks for watching. If you enjoyed this video, don't forget to like, share and subscribe for more fascinating insights into the world of science. The journey through the cosmos is far from over, and together we'll continue to explore the wonders of the universe and celebrate the brilliant minds that light our way. Keep questioning, keep exploring, and never lose your sense of wonder.